Okay, welcome all. My name is Jake Saunders. I'm Managing Director and VP at ABI Research, responsible for custom research and consulting at ABI. I'm joined here by an esteemed panel, and today's session is going to be focusing on visions of smart city upgrades in Asia. And today I'm joined by a number of individuals. So we have Dr. Pasakon, who is Senior Executive Vice President at DEEPA. We have also Chris Bishop, Sales Director, APAC Marketing Director at Ipsotech. We have Samir Sharma, who is Global General Manager of New IoT Markets, Smart Cities and Intelligent Transport at Intel. And last but certainly not least, we also have Lianjie Su, Principal Analyst at ABI Research. Before we get started with the main discussion, I think we'd just like to get to know our panelists a bit more in depth, if we may. So if I may start with you, Dr. Pasakon, can you perhaps give us a bit more background as to what are some of your responsibilities, your areas of focus, particularly in relation to smart cities?
Thank you, Jake, and good morning and good afternoon, everyone. My name is Pasakon. I'm working for DEEPA. DEEPA is a Digital Economy Promotion Agency. It's a government under the Ministry of Digital Economy and Society, the Thailand government. So my job is to drive the smart city in Thailand. We are doing the policy, the roadmap of the smart city, and we invite the city to develop the proposal and submit to the government. And then we give them the incentive. So my job is the key driver of the smart city in these countries. Thank you.
Very good. Thank you, Dr. Pasakon. Next, we'll move to Samir Sharma. Samir, can you just give a bit more background on what are some of your daily responsibilities and areas of focus relating to smart city?
Absolutely, Jake, and thank you for having me. I'm based out of the San Francisco Bay Area, so thanks to the wonders of technology, I'm able to meet with all of you and speak with all of you, including our audience from my home. My role is a global role. I lead a team that looks at smart cities applications ranging from public safety to mobility to sustainability and resilience. And that includes everything from public safety cameras to traffic management, parking solutions, and so on, public transit applications, and so on. The simple charter for my team is to make sure that we are pulling together all the investments Intel is making in edge AI, edge computing, 5G and future networking technologies, and cloud, and put it all together so our partners can bring the best of Intel Inside-based solutions to the end users, which would be city leaders, transportation agency leaders, and so on. And so in that sense, I have a bit of a dream job working with partners, but also working with end users who are adopting technologies with Intel Inside. This is part of our focus within the company to shift from what used to be a PC-centric company and still is, addressing a big part of that market to becoming what we call a data-centric company. In other words, have the best solutions through our partners wherever there is data collected, stored, analyzed, or transmitted. And from a city's perspective, there's massive amount of data, as we'll get into that conversation later today.
Very good. Thank you, Samir. Next, we'll go to Chris. Chris, you're based in Singapore, so you must be getting a handful on the smart cities front. Can you give me a bit more background on some of your operational procedures and parameters are?
Yes, Jake, thank you very much for inviting me to participate in this forum. I'm based here in Singapore, as you can see with the image behind me, the very famous Marina Bay Sands Hotel and Complex. I work for Ipsotech. It's a British company. We have our regional headquarters here in Singapore, where we have a team of both sales and professional service engineers. Our route to market across the region is via approved channel partners. And it is through these channel partners that we're able to work with the likes of agencies in Thailand, in Singapore, Indonesia, Malaysia, etc. And through those relationships, that is how we deliver our artificial intelligence video analytics solutions to the end users. And that includes people who are involved in smart city programs.
Very good. Thank you, Chris. Dianjia, I mean, you're normally based in Singapore. I think right now you're in Malaysia, but perhaps give our audience a bit more perspective in terms of your roles and responsibilities relating to AI and smart city.
Yep. Thank you, Jake. Thank you for having me. My name is Dianjia, and as Jake mentioned, I'm a principal analyst at ABI Research, leading our AI and robotics coverage. I'm very happy to join as a panel member for this session, giving sort of a slightly different perspective on the AI deployments in smart cities. Just recently, we have just published a report looking at deep learning-based machine vision in smart city, which you can find on our website. And yeah, I'll be glad to share the findings that we have discovered while working on the report. Thank you, Jake.
Very good. Thank you, Dianjia. So let's get started. A note to our audience, as much as I'll be leading much of this discussion, and I've got a number of questions ready to go to put to our esteemed panel members, but I've also got the chat window open. So if you wish to submit some questions in written format into the Q&A box, I'll keep an eye on that in about 10 minutes in or so. We'll see what questions we can pull out from our audience. But I think with that, let's get started. I think we'll get started with yourself, Dr. Pasikon. So, you know, the focus clearly is on smart cities. Clearly you're based at Deepa in Thailand. So what sort of smart city applications are sort of gaining the most traction in Thailand? What sort of smart city use cases are driving adoption in your country?
Okay, in Thailand, the smart city, we classify the smart city into 7 areas, including the smart environment, smart energy, smart economies, smart mobility, smart living, smart people, and smart governance. So there are 7 sectors, but the most important that every city must have is a smart environment. So I think that every city must have this kind of problems or pain point. Some city may not have the problem with the mobilities or the smart people, but I'm sure that every city have the problem with environment, like floodings, PM 2.5 in Thailand is very severe today, and that's why the governments encourage that every city should have at least one smart environment. So that is very important, and actually the top requirements in the smart environments is about the waste management or the garbage management. So everyone produce like 1 kilogram per day. So sometimes we need to generate the energy, the power, the energy from the garbage. So this is kind of the technology that we are looking for. And the another use case, I think that most of the city, they also concerned about the securities, and they already have the CCTV. It's very popular that every city have at least a CCTV as a base. But how to make it smart? So we need some kind of the analytics on top of the existing CCTV. So the AI, the cloud computing, edge computing, it may be working together with another IoT sensor. I think this is a very common and very normal basic or infrastructure for the smart cities. Everyone know about the CCTV, but we do not utilize the power of the CCTV yet. It's just to replay if there is the case. We need some prediction, we need some warnings. So I think that the very important use case is about the top up of the existing CCTV or IoT that we have today. AI data from the sensor is very useful. So environment and security is, I think, is very popular and the top most requirements in the city. Right. Back to you, Jeff.
Okay, yeah. Thank you, Dr. Pasikon, for your input. So getting from that sort of security, analytics, waste management, and so forth. Samir, I mean, is that also your view? I mean, I remember you telling on one of the briefing calls that you visit a number of clients, a number of companies around the region. Just wonder if we can pick your brains. Is that what you're also seeing in terms of use cases and potential application adoption in different parts of Asia?
Yeah, I think I have observations very similar to Dr. Pasicon, and it's not just Asia. I think we see these common themes across the globe. When I look at the variety of use cases, I recognize the fact that the set of solutions you implement have to be hyper customized to the needs of a given city. At the same time, you have to find common themes across the globe, across certainly Asia, so that we can have scale and therefore bring the cost down. And when I look at those common themes, they've been around public safety, which is both, hey, I want less crime in my city, but equally importantly, I want people to feel safe. And it's around mobility, which is everything from public transit to traffic management to multimodal transport and so on. And then we have, thanks to, I guess, the pandemic conversation over the last year, a big focus on resilience and sustainability. In face of a crisis like that, how do we make sure that our infrastructure is adaptable, it's evolvable with, certainly technology aspects like over-the-air updates, but also the right policy framework, the right regulatory framework around it, so that we can quickly deploy the solutions as well as the data and insights we can get from those solutions. So yeah, I think the theme is very much consistent.
I mean, what about some of the, smart cities is an umbrella concept. So there's clearly a range of different use cases, but delving underneath in terms of underlying technology, software, has smart city applications matured, or is it perhaps some segments are maturing faster than others? Where are
yeah,
you
that's an excellent question, Jake. I think if I look at the history of smart city evolution, I don't think the availability of technology was the limiter. To really implement it, you got to have the right set of solutions, but you need to have the right policy framework, the right regulatory framework, and quicker decision making than what we are used to, right? Break down some of the silos within the city offices as an example would go a long way. In some strange way, while the pandemic impact has been a reduction in the budget available to the cities, it has also been an accelerator for adoption of digitization, because city smartness, technology, these things became not only an option, not only something that's nice to have, but suddenly became very fundamental to both keeping the citizens safe and reopening the economy. So everything from PPE compliance, Dr. Pasicon gave an example of camera and its capabilities. Those same cameras that were being used in the past to give speeding tickets can now be repurposed to get a snapshot in aggregate and say, are people respecting social distancing guidelines? And if not, can we do some public service announcements or messaging around encouraging people to do that? Simple example. But what we found was some cities had these evolvable pillars of technology and they could upgrade them. Others had done fixed function technology implementations, and they suddenly found themselves stuck with fixed function, non-evolutionary infrastructure that could not adapt to these new needs. So I think technology will continue to be available and sort of stay one step ahead of what the needs are. That's my take on it. But I think we need some of the other pillars of the smart cities implementation success recipe to catch up. And I'm confident that pandemic will be a trigger for that catch up to happen.
Yes, I think we've seen that. It's certainly accelerating a number of adoptions. Perhaps moving to yourself, Chris. I mean, in terms of smart city applications, without proper sort of software and application development, could potentially fail. What are some of the technical security and UI requirements? How do we make these these smart city applications success? Is it a question of iterating or fail fast? What's some of your thoughts on that? Chris?
Sorry, I'll just unmute myself. Apologies for that.
Okay.
I think we've all seen examples of software that has been developed quickly, deployed, and has then had subsequent issues. Certainly at Ipsotech, we have a proven methodology where the first thing we will do is listen to people like Deepa, the end customer. What are the requirements? And the pillars that you've mentioned, the different attributes that you're looking for. And that's really important because as much as technologists will have a wish list and say, we can do amazing things, If the end user finds that too difficult, the interface is not intuitive, people will not use it. And so really, when you're developing these applications, it's all about planning, defining how everything will work. What is the interoperability? How do you connect to different networks? The design phase, do you design for today and not for tomorrow? You need to look to the future. Applications will need to scale. And then it's about building, testing, having a robust quality assurance process, and then you deploy. And then as part of that deployment, you learn, and you can then use that learning as a sort of a reiterative or process to adjust your applications or your software, and then have subsequent releases. And our experience is the end user, the operators that sit in control rooms across cities and organizations, they're looking for an intuitive interface. So having an interface that's designed the way operators think, and having that understanding is really crucial.
Right. When I sort of taking on from there, I mean, Liang Jie, I think we have to bring into discussion AI. And we managed to get 3 or 4 questions in without raising it, but clearly there's an opportunity for artificial intelligence, machine learning to be brought to the fore in terms of supporting a range of scenarios. How practical is that? I mean, is it more of a marketing term? What are some of the tangible benefits that AI can be brought to bear for smart city type solutions?
Yeah, good question, Jake. So for AI, it is always about sort of, I think, going back to what Chris and Dr. Pasakon mentioned, it's about what the end user wants at the end of the day. And in a smart city scenario, I think at the moment, what we are seeing is that AI has been deployed quite intensively at the surveillance system sector. So a lot of the the legacy surveillance systems, they are relying on legacy cameras. They are now getting an upgrade through an cloud-based AI algorithms to do video analytics and sort of maybe object classification to sort of detect threats or anomalies within an environment. This is what we sort of perceive to be sort of like the early phase of AI adoption within smart city. Moving forward, there is going to be a lot of activities around sort of how do you make sense of various time series data being collected across different verticals within the city itself. So I think there were talks about sort of collecting data from mobility services. They are talking. There's data coming from smart spaces, and how we can utilize those data and then make sort of the city itself more intelligent, more hospitable to its to the residents. The challenge with that is that it's not as easy as sort of just clicking a button and then the AI algorithm will run. It does require a whole set of not just policy frameworks, but also technology stack that enable AI to be deployed in both cloud and the edge. And that's where I think players like Intel comes in, so providing that that computing power that is required to power an AI solution. Because let's face it, at the end of the day, AI is not just a business case problem, it's also a technology problem. And having the right tools will only accelerate the whole adoption curve.
Okay, well, that comes up to my very next point. And I want to sort of get the foundations covered before we sort of delve more deeply into some of the use cases, more specific scenarios such as intelligent transport, or sort of waste management and such like. But so I think, Samir, I mean, clearly there's a lot of focus on cloud, a lot of data centers. Obviously, there's Azure, AWS, Google Cloud, and so forth. So there's cloud has got to be part of the picture. There's also a lot of discussion about the edge and trying to improve storage and compute functions at the edge. Where do you see the balance? Do you see for smart cities that more that processing, compute, and storage will be in the cloud, or will it be in the edge, or somewhere in between?
Excellent question, Jake. So let me give you a sort of a general framework of how we think about it and how we advise our customers and the end customers to think about it. And then I'll give you a couple of specific examples as well. So anytime you have a use case that requires very low latency, instantaneous real-time or near real-time response, you want to be close to the edge in terms of processing, because you cannot assume that the latency of going to the cloud, making a decision and analytics and bring it back will meet the needs of the use case. A great example is in the cities of the future, you may have drones or fleet of drones doing certain functions. Even today, you can have smart traffic intersections that can look at the depth of traffic and adjust real time the red light, green light timings to make the traffic flow better, right? Or to advertise the availability of a parking spot. These are all examples of low latency use cases that you want to be able to do at the edge. The second criteria for edge would be anytime you have uncertain network coverage. If whatever you are trying to work with is moving and maybe moving between network coverage, or you cannot guarantee coverage. I mean, this is not a smart city application, but we've got an agricultural customer where they cannot assume that in a field, in a farming field, you would have guaranteed coverage. So they have to make sure there is some edge computing available, and they cannot always assume perfect network connectivity. And the third criteria is privacy. The more you extract metadata, the more you annotate it before sending it to the cloud and storing it, the less potential you have for exposing the data, by mistake. So anonymizing the data at the source is one of the better ways to guarantee privacy and security. So now if you take these sort of criteria and then you say, okay, let's apply it to a camera situation at a traffic intersection. I gave the example of a near real-time case where you want to adjust red light, green light timings. That's something that's near real time. But another application for traffic data would be if you're trying to capture information by time of the day of the week, month of the year to analyze traffic patterns. That is not necessarily near real time or real time data. That can easily be done in the cloud. So I think it's less about thinking about a use case as suitable for edge or cloud, and more around underneath that use case, what kind of data are you looking for? And therefore, does your application require real-time analysis or non-real-time analysis? Does it require network coverage, or can it be resilient to non-network coverage? Does it require an extreme form of privacy, or is this data anonymized data that can be transmitted and stored in the cloud? I think if you look at all these factors, you can usually come to a good balanced decision about where to host what kind of capabilities and where to put more compute, what kind of network connectivity to use. Right. I'll wrap up my question by sharing another data point. If you assume a cloud-only scenario, last year, cities created about 16.5 zettabytes of data. I was sharing with all of you that given the late evening time, I had a cup of coffee before I came in. And if that cup of coffee represents 1 gigabyte of data, this is enough coffee to fill up the Great Wall of China, the entire Great Wall of China. And, and that is not the total data, that's the incremental data. Now imagine shifting all this data. Most of it is not very useful, right? Watching cars go by is not a useful piece of information. You want to know, is congestion building up? Did an accident happen? Did a parking spot become available? And so being selective about what you transmit, what you keep, what you annotate, what you extract as metadata, that's very critical to make sense out of this data tsunami. That's not just coming our way, that's already upon us as we speak. So hopefully this gives a framework as well as the enormity of the challenge if you don't think about these in a balanced way.
Yeah, that's very comprehensive. Yes, you say zettabytes. I'm trying to recall that is. I remember exabytes is 10 to the 18. I think zettabytes must be, I think sort of 21, 10 to the 21 or something like that. So that's an awful lot of traffic.
Jake, I'm impressed. Very rarely has anybody answered that quiz correctly on the first try. It is 10 to the 21.
I think, okay, well, I'm glad I'm right, because I used to do traffic forecasting. So very good. Maybe Chris, getting your perspective, and with your company's focus on AI and vision-based systems, you seeing a lot of AI in your sort of integrations, and in terms of edge versus sort of cloud-based compute and storage function? Where are your clients keeping their compute and storage capabilities?
It really depends on who the stakeholder is. What we find with government agencies or government entities is as soon as you have GDPR as a concern, there is a preference to have on-prem storage because it's data that needs to be kept secure. When you move into the commercial sector, and I would use Singapore as an example, you look at the number of apps that are widely available for you to download. Having that data in the cloud means wherever I am, I'm connected. Whether I'm underground on the SMRT network, I'm on a bus coming to work, or on a ferry, the data is there and accessible to me. And so in that instance, having cloud-based storage is really important for the end user, which is in this case, the population. The population complain very quickly if there's a problem with an app or the bus is late. Where's the data? Why is it not working? But in those instances, its majority of it is cloud-based. Certainly, a lot of the higher security solutions that we've delivered, the servers are actually on-premise.
Very good. Okay, well, I think we've covered a number of dimensions on the technical front. So let's perhaps sort of step it back and sort of delve more into sort of use cases. So I think prior to that, let's just talk about sort of business model use case. So Dr. Pasakon, what would be some of the better approaches, the better monetization or sort of motivation type models for stimulating smart city application deployments? I mean, I think we can see there's entirely sort of private enterprise, there's governments and perhaps sort of hybrid. How is it being implemented in Thailand? Is it very much being led by government efforts, or is it entirely being driven by private enterprise? How is smart city applications being rolled out in Thailand?
Okay, thank you. In Thailand, so we set up the Smart City Thailand logo. So any city that would like to become the smart city, they need this logo. So they have to apply for this kind of logos. Once they get the logo, they get the incentive, the support from the government. The support, for example, the Board of Investment, the BOI, they give the tax exemption for the private sector that do the smart solution for the smart city. They get a tax exemption. Another support, the city must have the city data platform is mandatory. So what is the city data platform? So everything is derived by the data. We need the data for the policy planning, data for the evaluation, and data for the operation. So we ask the city to open the data. For example, in Bangkok, the mass transit, the public bus, they have the equipped with the GPS, and then they open the GPS data. And there is the startup companies, they do the application for the arrival of the bus at the bus stop using the GPS data from the government. So I think the law of government, we try to local government to let them open the data, and the business like a startup can do the application or solution on top of this data. So we encourage the cities, the local government to collect and open the data. So this is our criteria. We want to make the ecosystem and to let them join the private sector, because the smart city is not only for the job of the government or local government. It should be the private sector. It's a PPP, people, public, private partnership. So not only the private, but also the peoples also. They have to get involved to feed the requirement. So by the law, the startup, they have a very innovative business models. So many new paradigms that they think about, sometimes they don't need the money from the government, they just need the authority from the government. So they can make the money from the data. They do the monetization for the advertising. So many kind of business models, the new one. They can use the data and sell the data for another business. So I think this is the new paradigm for the smart city, not just spending the government, local government money.
Is there a
So
sufficient
the government is a
training in place?
facilitator.
So, I mean, in Thailand,
yes, we did.
Don't need so much money, but what about training, education support? Is that needed for the workforce?
Yes, we also need the talent on the smart city. So we have the program called the ambassadors. The ambassador is a new graduate students, and we hire them to work for the cities. So they will be trained about the technology and the solution from maybe from the company, from the private sector, and then we send them to work with the city in the local cities. So we will try to create the new career path for the students once they graduate. So they become the smart city experts or smart city developer. So this is kind of the new curriculum in the university. And our low DIPA, we support by we hire the student for 1 year. And after that, the local government have to take in charge for hiring this group, these ambassadors. So this is kind of the workforce buildings in Thailand.
Okay, I think let's delve into some specific use cases. I think the three we're going to try and sort of focus on is sort of smart grids, intelligent transport systems, and then sort of building smart buildings. So perhaps Samir, I mean, what would be, clearly we've already got electrical systems, electrical grids. What's the rationale in terms of making the electrical systems, the grids more intelligent, smarter? What are the potential benefits from going down that route in terms of a smart grid type architecture?
So I think if you look at the grid implementation, right, and you look at the opportunities for both efficiency, which comes down to or translates into cost savings, as well as resilience, which comes down to the fact that you always want these grids to be always available, always on, and supplying electricity to the every system, virtually every system in the cities. I think having that resilience and having that efficiency are sort of fundamental requirements, right? Predictive maintenance. There's a lot of analytics that are run on the voltage fluctuations, as well as making sure that we are managing the demand supply curve effectively, including dynamic pricing. So if you start looking at all of these as massive data crunching, data processing opportunities that pay back in terms of efficiency, in terms of resilience, in terms of a better experience for the end customer, I think grid modernization has become a national imperative because of all of these in multiple parts of the world. Kind of a complementary aspect to it is also this idea of microgrids. And I think it's sort of related to the earlier notion of edge computing that we were talking about. This ability to disaggregate and have grids be turned on at a smaller scale, at a campus level, at a building level, and give it some localized resilience as well as efficiency, I think is another promising, sort of benefit of thinking about, electric grids and their modernization.
What are some of the bottlenecks? What are some of the challenges still to be overcome? I mean, it can't be plain sailing. What are the sort of major challenges, issues to affecting a reliable smart grid?
If that is a question for me, I think part of it is reflective of some of the discussions we had earlier, right? Which is, hey, what are the funding sources for this? And in many countries, the utilities are they have a rate control system because they have to pass on the incremental spending onto the customer or the consumer, the end consumer, which requires its own set of approvals. Sometimes the economic incentives are not tuned towards maximizing the efficiency. And there is a bit of a paradox here as well. On one hand, the electric utilities want to be efficient. They want you to conserve energy. On the other hand, the product they are selling is energy and electricity. So they would want you to use more of it. And the way this paradox can be best explained is it's not really a complete net demand, net supply issue. It's more of a timing of that demand. Getting up in the morning, coming back after the rush hour, starting everything at home. These peaks require the utilities, because they have an obligation to supply electricity, to buy expensive energy credits from the open market or electricity from the open market. Now, some of this can be alleviated through more efficient storage practices and so on, but that's the fundamental, demand supply gap at selective times of the day and times of the week that they have to struggle with. So I think overall, it's a number of these small issues, relatively smaller issues that add up to making this a very challenging industry to transform. But what we're noticing is the momentum is adding up, and I think it's reaching a bit of a tipping point.
Very good. Lian Jie, I mean, there's going to the discussion about AI, there's a lot of also references to machine learning. I think for our audience, can you just really delineate the differences between AI and machine learning and how the two approaches would be perhaps utilized in a sort of series of smart city applications? Which type of use cases would perhaps be more heavily dependent upon AI versus machine learning and so forth?
Yeah, sure. I'm happy to take that. So the fundamental difference between AI and machine learning is that when we talk about AI, we kind of looks at the sort of what we call, or what the industry called as legacy or classical AI. Basically, it's a rule-based engine that is sort of formulated by a series of if-then functions, and then it's being guided by a set of hard-coded rules, which is based on human intuition and judgment. So which means classical AI generally relies heavily on human intelligence, on the domain expertise of people who has been working in a particular field for a very, very long time. And this applies to, say, the traffic management systems, or it can be like what Samir mentioned earlier, like in smart grid, as well as in sort of smart meter scenario, where you have a certain spikes or certain anomaly within a data set. Generally, and human expert will be able to identify that and then hard code it as a anomaly, or as something to be addressed at the end of the day. So that is where generally classical AI is being deployed. As sort of the deployments of devices getting increasingly sort of abundant nowadays, these devices generate a lot of data, and that is where machine learning comes in. Machine learning algorithms thrive at the amount of data that you can feed it to. So classical machine learning algorithms, decision trees, KNN, they are great at making decisions based on a large amount of data. They are able to find anomalies within a data set, generally through a very supervised manner, like you will guide the algorithms to find either clusters or certain association within a data set. And then through that, it will form its own parameters and then comes out with its own decision systems. So that's where sort of machine learning helps, in the sense that instead of relying heavily on human experts, you will actually rely on data set itself to generate different parameters, and then augment that with human in the loop, so to speak. And I think one of the best sort of use cases to demonstrate this is actually in machine vision applications in smart cities. So a lot of the smart cities surveillance system nowadays rely heavily on deep learning, which is a subset of machine learning, and sort of that deep learning algorithms actually has an accuracy level that is close to a human expert level. So the idea is that because generally in a smart city scenario, a lot of the city councils are facing budget constraints, as Samir mentioned earlier. You may hire a lot of people to address a certain set of problems, but that will not really help to boost your top line or sort of help you save your operational costs. So that's where having sort of like a machine learning AI, they are able to find its own parameters and sort of develop its own decision system at the edge, in the cloud, will help tremendously with the operational efficiency of a smart city at the end of the day. So I hope that that helps a little bit, Jake.
Indeed, yes, it is. I think it's pertinent to have those two together, two concepts fully delineated. Chris, I mean, in terms of Ipsotech, how much is Ipsotech reliant on AI and or machine learning type process? I mean, are you up to your elbows in code, or is that perhaps done by people back in the UK? But just wondering, do your customers have certain requirements in terms of how much is controlled by sort of AI type function, or is it more just about the use case?
It's really about the use case, Jake. An example I could give is, you know, in some train stations, train operating companies, bicycles are not allowed to be ridden on platforms. So we're able to teach our neural network what a bicycle looks like with a person. You know, likewise, we can teach the system, you know, what somebody in a wheelchair looks like in a crowd of people. So that's a health and safety consideration. It's of benefit to the individual, because as they come into the station concourse or the ticketing area, an alert is raised and somebody can then assist them to the lift, take them to the platform and ensure they get on their train. That's customer service, that's customer satisfaction. And so that has a different implication versus, say, us teaching the system that if somebody loiters in an area for a period of time, why are they doing that? But they keep coming back to the same area. And so you then raise a different alert, which is more to do with, say, security. So the system we have is, or our software application is very versatile, is relatively straightforward for us to teach new models, but it is always driven by the end user, by the customer.
Very good. Samir, I mean, so we've touched upon AI, we talked about a lot of data, and clearly there's some aspects around privacy we need to talk about, or ensuring security of data. Systems are apparently being hacked, but how should governments or companies go about managing the data portfolios, or just ensuring that they have the right governance in place to ensure that, you know, they're trying to mitigate as much as possible the issue of malware or being hacked, and to ensure the privacy of people's data?
Great question, Jake. And the reality is there is no one size fits all recommendation for every part of the world, because this notion of privacy is not binary, right? It varies depending on the cultural nuances, depending on the legal and policy frameworks, depending on the demographics. But there are some areas where I think where technology can help, right? Certainly things like encryption at the hardware or within software are a great way to secure the data that's being collected. But also, as I may have mentioned this briefly, the ability for the edge computing capabilities to look at that data real time and say, I don't need all this, as an example, personally identifiable information. If my objective is to track traffic density versus pedestrian density during a particular time of the day to figure out if this is a risky intersection, I don't need license plate numbers. I don't need faces of individuals. All I need is an extraction of the data that basically says at this point in time, this is the density of traffic in either direction, and extract that data and keep that data. So I think I always like to remind people that when it comes to people love the fact that technology can help them, but they are concerned about personally identifiable information. So when you are engaging in a project, make sure you publish what, if any, personally identifiable information is being collected and retained. And if it's not being collected and retained, be vocal about it, be explicit about it. The second recommendation I always make is prepare what I would call a data manifesto. This is not a legal document that I'm describing. It shouldn't require 10 lawyers to read it, interpret, and understand it. It should be easily understood by an average citizen who can read it and say, okay, I get it, what you're trying to accomplish. This is the kind of data that will be collected. And this is how it will be anonymized. And this is how it will be stored. Explain in simple terms. And what that does is it establishes trust. And when you have trust, people don't assume the worst. People assume the best out of what you're trying to do, what you're trying to accomplish, and how it will benefit them. So I think stakeholder management, the right use of technology, transparency in what data you're collecting and how you're using it, and finally, avoiding, if you can, personally identifiable information. Those would be my 4 tips to go tackle this rather complex, conversation and question.
No, appreciate that. It was good to tackle it. We're coming towards the end. Perhaps we'll run for another sort of 5 minutes. If there's any questions from the audience, more than welcome to take it. But perhaps we'll sort of be wrapping up in the next sort of 5 minutes or so. Perhaps just coming back to you, Dr. Pasakon. In terms of sort of one sort of prime use case, I think would be, in addition to smart grids, intelligent transport systems. Clearly, Thailand's got a very strong economy, a growing population, a lot of aspiring expectations. What is Thailand doing on the intelligent transport system front in terms of managing traffic flows and so forth?
Okay, in Thailand, we, like in Bangkok, we have a lot of the new train, the new line of the sky train and subway. So we try to move the people from individual vehicle to the public transport. And the problem is in the last mile and the first last mile, because once they move from the change from the public transport to the from the individual transport to the public transport. So they need the last mile, and then I think that I think the technologies could come. You may heard about the wording of MaaS, Mobility as a Service. So I think that once people don't need an individual car, they don't need to own the car, but they need the service to go from point A to point B. So that is the mobility is become a service. So, but in Thailand, the facility like e-ticketing, the e-payments for the public transport is not connect in each vendor in this authority yet. So that is the problems. So, but we expect that at the end, we have to integrate the public transport, the public service, and make the mobility as a service. It's like a one broker that can provide the service from the taxi to the bus to the train. It should be integrated. So I think this is the target that we're moving for. And I think every city are looking for the MaaS, the multi as a service. So we are also.
Right. Okay. So the last question is to you, Samir. In terms of, we talked about the architecture, a number of sort of key use cases. What about some of the economics? So a lot of this will be enabled by IoT modules. We're going from 4G to 5G. Do you see a lot of these smart city platforms will be using 5G equipment, or will it be 4G? What's your sort of view of how things will evolve over the next 5 years?
I think 5G will be a game changer. I'm very convinced. Having spent more than 20 years in the industry, I've seen the transition from 2G to 3G to 4G, and now we're talking about 5G. And in every sort of conversion or transition, the phone was at the center of it all. For the very first time, we're designing a network ground up that's more around sensors from low end to high end. We have devices that are high bandwidth, like cameras, 4K cameras today, 8K cameras in the future, to water meters that are going to tweet consumption once a month and then sit quietly. And this network is being designed to accommodate all of these and the economies of scale that come with it. So I'm very bullish that 5G will be a game changer. However, having said that, we don't need to wait for 5G to implement a bunch of these ideas. I think the connectivity modules available today, as well as a variety of sort of other kind of solutions like NB-IoT and LoRa and Sigfox that are still competing in the market with each other, I think give you enough flexibility of options to go implement something. Now, if I take a step back and I talk about the cost of implementation in general, if you truly implement an end-to-end IoT solution in the right way, and you take that data and you take action based on it, I can assure you that if you've done your homework, the ROI will easily justify the investment. And think about your investment if you're a city planner or a transportation agency leader. Think about your investment not just in terms of your IT budget. Think in terms of your total budget and how instrumenting the physical assets, the physical infrastructure you have with the corresponding digital twin and digital infrastructure can A, help you utilize the physical infrastructure more effectively, but B, also make that infrastructure more evolvable, more flexible. The point of, when we talk about traffic management, there is sort of a tendency to say, let's go make more roads. Let's expand the number of lanes. Expanding the number of lanes is not the end game. Moving people more effectively is the end game from point A to point B. And if that can be done by optimizing the system of systems across the city, by routing traffic away from congestion points, by making more parking available so people are not driving around the downtown, waiting to find a parking spot and creating congestion in the process. We can do all of these things. The ROI pays for itself. So I would encourage anybody listening in to think at this, at the investment and the cost problem, not purely as a cost problem, but as an ROI analysis.
Very good. Okay, I'm gonna just do a quick round robin set of questions as we wrap up. I'm just curious as to I'll ask each of the panel members, you tell me the two sort of use cases you think would be the best to pursue. If I was a startup, I was going to each one of you and I'd say, well, what are the two main areas, the two main use cases should I invest my time and my money in to get the most return on investment? What would they be? So I think we'll start with you, Samir, first. Which two use cases in the smart city portfolio, from grids to ITS to smart buildings, eco-management, security, smart utilities? It's quite a range. Which ones would you be investing your money in?
I mean, I would, if I had to pick a choice about investment, I would definitely be investing in AI-based camera vision capabilities, because to me, if it effectively gives the infrastructure the ability to see, hear, interpret, and act. And that's a very powerful transition that you cannot go wrong on. What exact path it takes may vary, but that capability is here to stay for the foreseeable future and will only increase in value.
Very good. Okay. Let's go to Chris. Chris, what would be your one or two areas of sort of top investment? Chris?
Turn my mic on again. If I was a software developer looking at smart cities, I'd be looking at what does the population use? Everybody has a smartphone and everybody goes to work. If you're moving people from the road into public transport, the one thing passengers want to know is the bus on time? Is the train on time? Are there any issues? I'm here in Singapore, there's an app that broadcasts if there is an emergency, and everybody has this app. Many other countries who are moving into this smart arena, this smart city arena, do not have that capability. And I think citizens benefit from that. So if I was an app developer, that's what I would be looking at.
Very good. Lian Jie?
Yeah, I think increasingly there is sort of more and more attention on sustainability and waste management. So that's perhaps something that that city itself are trying to look towards in trying to become greener and perhaps more sustainable moving forward. But I think equally at the same time, there is a lot of effort being spent on, I think, as what Chris and Dr. Pasakon mentioned earlier, mobility as a service is going to be like a pretty dominant area, because I think just because of the rise of intelligence of transport system, as well as sort of the increasing number of sensors and cellular V2X that's being deployed in a smart city infrastructure. I think mobility as a service is going to be a top bet for innovation.
Okay, thank you, Lian Jie. And Dr. Pasakon, what would be your most preferred app to invest in if you were starting out?
Yes, yes, I have mentioned earlier about the smart environment, and smart safety or smart living. So this is the top tools. But I would like to add more about the technologies. So I'm looking for the blockchain technology for the city development. So there's a lot of opportunities. So we talk about the 5G AI, but how about the blockchain? We can do the more transparency for the smart governance, for the voting paradigms, or many kind of even the city coin using in the city. So many opportunities using the blockchain. So I think that maybe you can think about it.
Nice. Okay. That's food for thought. I've been scribbling away furiously, taking down all your notes, and I'll get busy. So, okay. Well, I'd like to thank all our panel members for participating, providing their expert opinions. So thank you very much, Dr. Pasakon. Thank you very much, Samir Sharma. Thank you very much, Chris Bishop, and also thank you, Yan Jesu. So with that, we'll wrap. If anyone still wishes to submit a question, you can still send it into ABI. We can perhaps follow up as an offline discussion item and see if we can get back with some expert opinion. On that, well, thank you. Have a good day.
Thank
Thank you very much.
Thank you, everyone.
Yeah.
Have a good day.